tomorrow's quiz. Please be here to take it. Nobody wants to spend the next 10 days reviewing for your quiz because you're not going to over the break. So be here and take the quiz, all right? We're doing nothing else other than the quiz. It will not take the whole time. You'll have the whole class period, but it won't take the whole thing. There's 7 questions. 2 or 4 of them are super basic, and then there's a couple where you have to think a little bit. But if you have a question like this, actually, I want you guys to write this down. These are our quadrant angles, remember? Quadrant meaning 90, 180, 270, 360. Pi over 2 pi, 3 pi over 2, and 2 pi. You guys need to know the ordered pairs there, but you should, look. When you start at 0, think about if you're going to go to the right, it's 1 unit, and you didn't go up or down any. If you start at 0 and you go to the left, that would be -1, right? If you go up, it's +1, and if you go down, it's -1. But you guys need to know those ordered pairs at our quadrant angles. 90, 270, 180, that sort of thing. All right, so these first few questions, when it says, what quadrant does the angle lie? That's our all students. Top right is A. Some of you yesterday, when you're coming to ask me questions, you put the A in the top left. You got to make sure that it's in the right spot. Remember, look at the first constraint first, then the second one. The first one says cosine is less than 0. That means cosine's negative. So what can I cross off? A, because everything's positive there, and where else? C, because cosine's positive there. Good. My second constraint, cosecant goes with sine, correct? Says sine's positive. So with what's left over, where is sine positive? In the S, quadrant 2. All right? Super basic, I promise. Look at the next one. Same thing, all students. This is a very important concept so you guys know for the problems which x and y is negative, positive, that sort of thing. So your first constraint says cotangent and tangent are greater than 0. That means positive. So what can I cross off? S and C, because in A and T, cotangent and tangent are positive. So my second constraint says secant, which goes with cosine, is also positive. So with what's left over, where are both those trig functions positive? A. Yep, good. So quadrant 1. All right, next one. Good job. All students take calculus. My first constraint says sine is negative. So what can I cross off? A and S. Good. My second constraint says secant, which also goes with cosine, is positive, greater than 0. Where is cosine positive? In quadrant 4. C. Good. Anybody have any questions about that? 2 of the 7 on your quiz are that. It's a very important concept. All right, again, I'm going to put the answers up. I changed number 5 just a tad. Go ahead and change it with me. Different kind of a look. Remember, you guys are allowed to, you're going to have your calculators, but it's going to ask for exact answers. Do I want decimals with exact answers? No. So in this case, guys, some of you were asking me yesterday, I don't get how you gave us the constraint. The first thing you should do, because you're given an angle that is not on the unit circle. You're given an x and a y. In this case, guys, you have x, you have y, and we have to find the r. Or you might be given the x and the r, you got to find the y, whatever. But the first statement says cotangent is square root of 10 over 3. Your cotangent and your tangent are positive. So that is your first constraint. What can I cross off if I know that tangent and cotangent are positive? S and C. Perfect. The second constraint says that sine is negative. What I have left over, what can I cross off? A. So I know my angle is in the third quadrant. Why was that really important for me to figure out? You need to know that both x and y are what kind of numbers? Negative. So you're going to come up here and you're going to say, ooh, my x is negative and so is my y. If you did not do that, you're going to get the signs wrong. The signs are the most important thing here. So think about what cotangent tells you. Cotangent is what over what? X over y. So your x is negative root 10, and your y is negative 3. Now, the rest of this problem is super easy. How do you figure out what the r is? It's the Pythagorean. X squared plus y squared equals r squared. What's negative root 10 squared? Just 10. Plus, what's negative 3 squared? 9 equals r squared. So 19 equals r squared. So r equals the square root of 19. If that were to break down, what should we do? Break it down, but it doesn't. Now to find all the trig functions, guys. This is super easy. You're not going to be asked to find all of them. You're only going to be asked to find one or two, just for time's sake. But let's go through this just to make sure we understand. We're with me. Sine is y over r, correct? Cosine is x over r, good. Tangent is y over x, good. So my cosecant is r over y. My secant is r over x. And my cotangent, excuse me, is x over y. So, y over r, this is all I need to look at right here. I have negative 3 over the square root of 19. Is that okay? No, we need to rationalize. This is actually going to become negative 3 root 19 over 19. If negative 3 on the outside and 19 simplified, what should we do? Simplify it if it does. You guys have a calculator. So my cosecant, I'm going to flip it. It's the square root of 19 over negative 3. Anything to do there? Nope. Good. Yeah.
We're only receiving like a fraction in that circle?
Yep. But you don't need that right now. Okay. This isn't a problem that you need it. I'll show you one that you need. All right. Cosine is x over r. So square root of negative 10 over square root of 19. Is that okay? No. Guys, a house times a house is just a what? Bigger house. This becomes the square root negative of what? 190 over 19. Does the square root of 190 break down? It doesn't. No. But if it did, what would we do? Break it down. Okay, so then over here we're going to do the exact same thing of the square root of 19 over square root of negative 10. What do? Same thing. So negative square root of 190 over 10. Can I simplify that? Doesn't 10 go into 90? 190? It does, but you can't because one's inside, one's outside. If they were both inside of a radical, you could, or if they were both on the outside. And then tangent and cotangent. Well, they already gave me the cotangent. That was given in the problem, right? Square root 10 over 3. So then my tangent would be 3 over square root of 10, which we can't keep, so it's 3 root 10 over 10. The easy part, guys, is finding the trig functions. The hard part is assigning your negatives with your x and your y and figuring out what goes where. Yeah.
For the given, did you add in the root for 10?
Yeah, I changed the problem, yeah. On a couple of them I changed just to give you guys a different look on things, yeah. All right, so reference angles. You guys are absolutely going to have a question that just says, here you go, find the reference angle. Super easy. What did I write here? If you start in degrees, your answer should be in what? Degrees. If you start in radians, your answer should be in what? Radians. What are two things that we need to remember about reference angles? They're always what? Always acute and always positive. Very important to remember. So how do we find reference angles? Well, first thing I'm going to do is I'm going to draw my angle. The given angle is 265. You guys agree with me that 265 is in quadrant 3? Yeah? It's in between 180 and 270. So your reference angle is formed by the terminal side and the x-axis. So what's the rule for quadrant 3? Angle 265 minus 180. What's 265 minus 180? 85 degrees. Okay. Is that number acute? Yes. Is it positive? Yes. Okay, you're good. Let's look at the next one. We're starting off in what? Radians. So we need to end up in radians. I'm going to go ahead, since we think better in degrees, I'm going to convert it. So this becomes what, 30 degrees? Well, where is 30 degrees, guys? In quadrant what? Quadrant 1. What's the rule for quadrant 1? It's just that angle. So is my answer 30 degrees? No, it's, what's my answer? Pi over 6. Why is my answer pi over 6 and not 30? Because you got it. We started in radians. Good. All right, good, good, good. Yep. No, I just always like to. Is that negative important? Yeah, so make sure we keep it there. Let's go ahead and convert. So I have pi on the bottom, 180 on the top, so my pi's cancel. 3 goes into 180, 60, so I have negative 7 times 60. What is that? Negative 420. What do you notice about negative 420? It's negative and it's greater than a circle. So add a circle. So plus 360. I get negative 60. Still a negative number, correct? So let's add another circle. I should add not the answer. So what's negative 60 and 360? 300. Okay, so where is 300? Here's 270. Here's 360. It's over here, right? Quadrant 4. What's the rule for quadrant 4? 360 minus the given angle. So 360 minus 300 is how much? 60 degrees. Is my answer 60 degrees? No, I have to go from degrees to radians because we started off in radians. So 60 goes into 61, 60 goes into 180. How many times? 3 times, so it's pi over 3. Questions? All right, last one on this. Let's go ahead and convert. So pi on the bottom, 180 on the top. 5 goes into 180, 36. Yes, sir. What? Yes? All right, so 36 times 12. 432. What do you notice about 432? It's bigger, so let's take a circle away. 432 minus 360 is how much? 72? Okay, 72 degrees. Is that number acute and positive? Yes. So, guys, think about where is 72 degrees? It's in this first quadrant. So what do you know 72 degrees is? It's the given angle, but it's also your reference angle. So then we just have to convert back. So 180 here, pi here. 72, what goes into both? 9. So this is 8, and this is 20. 4. So 2 and 5. So 2 pi over 5. You guys have questions on reference angles? All right, that's another 2 questions on your quiz. So 4 of your 7, something like that. And you also have one like with given the cotangent is this, find this and that. So that's 5 of your 7 questions right there. Here's how you do the last 2. Notice I changed these numbers. Look at 12 and 13. I changed them. It says use reference angles to evaluate. This is the question that you're going to get the first quadrant of the unit circle. You're going to get the first quadrant of the unit circle. So at 45, your ordered pair is root 2 over 2, root 2 over 2, right? What's the ordered pair at 30? Look at it. Don't just guess. It's either root 3 over 2, 1/2, or 1/2 root 3 over 2. Look at it and tell me. It's root 3 over 2, 1/2. And then what's the ordered pair at 60? 1/2 and root 3 over 2, okay? So here's where, guys, when it says use reference angles, this is the question that you're going to get the first quadrant of the unit circle. And you have to find what the reference angle is, and then you're using your all students take calculus to figure out what the signs are. So I changed this. Okay, look, I changed this to 300. Sorry, Al, go ahead. All right, I changed this to positive 300. So where is positive 300? In what quadrant? The what? Okay, whew, scare me. Now, why is this important? What are the signs of X and Y in the fourth quadrant? X is positive and Y is negative, correct? That's important because now to use reference angles, if it's in the fourth quadrant, you say 360 minus 300 and you get what? 60 degrees. Well, what's the ordered pair at 60 degrees? One half and radical 3. Okay, so it's 1/2 and square root of 3 over 2. But since we're in the fourth quadrant, what do you have to do to that to the root 3 over 2? It's actually negative. Now you just take this and you say, okay, what are the trig functions? Well, think about this. Since we're talking about an angle that's on the unit circle, your R value is what? 1. You can use R over Y, X, you could use that, or you can just use, since it's on a, since we're on the unit circle, this is your cosine, this is your sine. So what is the sine of this angle? Either way, because it's on the unit circle. Or if you do X, Y, R, Alec, that's fine too, because your R value is going to be 1. So your sine is negative root 3 over 2, right? Your cosine is 1/2. And then your tangent is Y over X, right? So root 3 over 2 times 2 over 1 becomes negative square root of 3. And then our reciprocal functions, cosecant, is going to be 2 over negative root 3. We can't leave it. So it's going to be 2 root 3 over 3, with a negative out in front, correct? We rationalize, okay. When I flip my cosine, my secant becomes 2, good. And then my cotangent, when I flip it, becomes what? Negative root 3 over 3. When you flip root 3, guys, it becomes root 3 over 3. Again, the hard part is not the trig functions. The hard part is saying, okay, what's the ordered pair I'm looking at? What quadrant are we in? That sort of a thing. All right, look at 13. Again, let's convert first. When you are asked to use reference angles, it will be an angle that's in the first quadrant. If you do your math wrong, don't come up and tell me I did something wrong. You did something wrong, so just pay attention. You guys have a calculator, okay? Our pi's are canceling. All right, guys, let's finish up. Here we go, look. 6 goes into 180, how many times? 30? What is 7 times 30? 210 or 220? 210. Okay, so where is 210? Let's talk about 210. Where is 210? How'd I do what? 7 times 3? So quadrant 3. What's the rule and what do we know about quadrant 3? What are the signs in quadrant 3? Negative, negative, good. And then what's the rule for the, angle minus. So what's 210 minus 180? 30 degrees? Okay, so what's the ordered pair at 30 degrees? It's root 3 over 2, 1/2, right? It's root 3 over 2 and 1/2. But Chris said they're both negative. Why are they both negative? Because you're in the third quadrant. So you are evaluating with negative root 3 over 2 and negative 1/2. So here's your cosine, here's your sine. Now can we do the rest of it? Yes. Uh-huh.
So if we do our math right, we should always get like.
If it says use reference angles, you will either get 30, 60, or 45. Yep.
Not like any negative. You should know flip.
If you know it, that's great. But if you don't, it's no big deal. All right. Then you will have a question that looks like this. It says evaluate. These are special. You'll see why they're special in a second. You guys don't have these. Just take a picture. First thing I'm going to do is I'm going to take 9 pi over 2. And I'm going to convert it. Good. Pi's cancel. 2 goes into 180. 90 times. 810 degrees. Okay. Well, that's way bigger than a circle, right? Can I take 2 circles away from this? You guys okay with me with doing that? Okay, so I'm going to take 720. 360 and 360. What's 810 minus 720? $90 degrees. All right, what kind of an angle is 90 degrees, guys? It is a right angle, but it's one of those quadrant angles. All right, so what is the ordered pair up here at 90 degrees? It's 0, 1. You're gonna have one that is one of the quadrant angles. So if I want the tangent, all right, so 90 degrees. What is the ordered pair at 90? It's 0. This is my x, and this is my y. How do you find the tangent? What over what?
Y over x.
It's y over x. So if I take, if I take my y, I have 1 over 0. What is that? Undefined, right? Undefined. You will have one that is one of your quadrant angles. That should be an n. Remember, when 0 is in the denominator, it's undefined. If it's in the numerator, then it's 0. So again, same thing over here. Figure out where negative pi over 2 is. Some of you can do this already in your mind. Some of you can't. It's no big deal. If I take negative pi over 2 and I convert it, where is negative pi over 2? It's negative 90, right? Well, negative 90 just means you start at the positive x-axis and go down. But if that doesn't make sense to you, add a circle to it. What's negative 90 and positive 360? It's 270. Okay, so let's think about 270. Here's 270. What is the ordered pair at 270? 0, negative 1. So, okay, I have my values. Now, this is on the unit circle. So you can use 1 over, or you can say x over r, y over r. It doesn't matter. But what is cosecant the reciprocal of? Sine. So since this is on the unit circle, you could say that sine of theta is 1 over y, or you could say sine of theta is, cosecant. That's what I meant, but you could say cosecant of theta is r over y. Why can't I use either one of those interchangeably? Because it's the same thing. Since we're on the unit circle, your r value is 1.
So every r value is always on the unit circle?
On the unit circle. So I have, my value is 1 over negative 1, which equals negative 1. All right, I just went over every single type of problem that's going to be on the quiz tomorrow. Bring a calculator. You guys will have the whole time. Nothing tricky, I promise.
Wait, you can calculate for it?
So, cosecant of theta is the same as 1 over y or r over y, right? So like the ones where you're given a point on the terminal side, or they tell you the cotangent is this over this, it's not on the unit circle. These two things are the exact same thing when the angle is on the unit circle, because any angle on the unit circle, the r value is always 1. The hypotenuse from the angle to the ordered pair is always 1.
So since we know y is 1.
Since you know that this is on the unit circle, it's not just a point on a random, yeah.